Hi, Lise. Good evening. How are you doing? I hope that you're feeling well while being confined at home. And I hope that your brother is feeling well. So I am creating this video for you because this is going to be your first virtual lesson for math. And what we're going to do today is we're going to do a lesson that we did just a couple of days ago with the class. And it's about methods and models for multiplication. And what does that mean? So, the idea behind this lesson is that you understand that multiplication is more than just remembering facts. So, if you have something like 3 times 4, and you know automatically that is 12, how do you demonstrate that you know that 3 times 4 is 12? Or how do you understand in real life that 3 times 4 is 12? So that is what our lesson is going to be about. The first thing that we're going to do is we are going to go to Google Classroom, go to Mrs. Mark's math class, and open up a post that I just created for you, and has 3 attachments. The one that I want you to open looks like this. Um, I believe that it is called. Hmm, let me see. Oh, it's called Teachers Masters. And once you open it up, I would like you to go to page T7. Look at this. It's right here, T7. I'll wait for you a second while you open it up and we will continue. You can pause the video right here. Okay, now that you are on the right page, what I would like you to do is to focus your attention on only this box of crayons. Okay, just like this box. Forget about this one, number 2. Now, what I would like you to tell me about the box of crayons number 1 is how many crayons are there in the box? And I would like you to be prepared. If we were in class, I would ask you to be prepared to share the answer and especially how you got it. So take 1 minute to think about it and then we will talk about it. So, if you have realized that in the box of crayons number 1, you have 8 crayons or per row, and then you probably thought in the lines of, okay, I have 8 crayons per row, and that will be times 3. So 8 times 3 would be 24. But you might have different versions of this thinking process. Depending on what you had told me in class, I would have modeled one of the strategies that we're going to be seeing during the lesson. I'm just going to imagine that, just for the sake of the discussion, that you saw the box of crayons and thought, okay, so there are 8 crayons per row, so I'm gonna skip count. I'm gonna say, okay, I have 8 plus another 8 would be 16 plus another 8 would be 24. What I would have done in class, or what I did in class actually, is to model that thinking with one of the mathematical models that we're going to be using during this unit. And let me show you what I mean on the screen. Let me go back to my sketchbook and I'm going to take a pen right here. And if you had told me that you had a skip counted, what I would have done is I would have created a open number line, which is one of the models that we're going to be using in this unit. And I would say, okay, so let's imagine that this is like I have an empty box of crayons. So if I have only one row of crayons, that would be 8. So I'm going to write it right here, 8. But I have 3. So after one row of crayons, I would say, hey, I have a second line. So that would be twice as much. So I would say that I have 16. But hey, this particular box of crayons has 3 rows of crayons. So I'm going to say, okay, we have one more row of crayons. That makes 24. So I would say, okay, if I had only one row, that would be 8. but it happens to be that I'm counting that there is, oops, I'm gonna remove that, that I have 2 rows of crayons, so that would be another 8. And finally I see that, oh, there is a 3rd row of crayons, so that would be a total of 24 crayons in this box. This way I can demonstrate not only how I think, but I can transmit my thinking to somebody else. That's why we are making so much emphasis on showing our thinking through a model. In this case, we're going to write the name of this model, and it's called an open number number line. We're going to see more models during the lesson, but I just want you to start becoming familiar with the name and how it looks like. Now, what I would like you to do is I would like you to go back to the document that we were just working on. I'm going to change my screen as well. There you are. And we're going to be focusing on the box of crayons number 2. And what I told the class at this point is that this box has twice as many crayons as box number 1. Therefore, my question is exactly the same. How many crayons are there in the box? Take 1 minute to think about it, pause the video, and we will come back and talk about it. Okay, now after 1 minute, I would have asked you, could you show me what model you use to represent this box number 2? Now, if you continued working with the model that we use for box number 1, you could have said something like this. Okay, Mr. Reyero, so right here we have 24. I mean, the open number line already says that. But you were telling me that this box of crayons number 2 has twice as many crayons as box number 1. Therefore, what I think I can do, I can just basically extend. I'm going to try to do it neatly. Ooh, that was not neatly at all. Okay, let's try once again. So there you are. I would have extended my number line and say, okay, oh, this is 24, so more or less, let me see. This much will be twice as much. Okay, and if I would say that, yeah, I'm gonna make it right there, more or less. So this would be another 24. Now, do I really need to do the intervals just like we did in box of crayons number 1? Not really, because I can see, okay, 24 and 24 is 48. And I'm representing this length right here up to here is exactly the same as from here to here. So I have already demonstrated that that this will be 48. But if I were very specific about it, I could say, okay, yeah, this is another 8 crayon interval. This is another 8 crayon interval. And this is another 8 crayon interval. So I could say that this would be certainly 32. This would be 40. And yeah, 40 plus another 8 would be 48. There you are. I have demonstrated with an open number line that 6 rows of 8 crayons per row is going to be 48. Now, the second thing that I would like to show you is like, how would this look like if I had used a different model? So let me use a second model that we're going to be using during this, this unit, and this is called a ratio table. I don't remember if you were introduced to this concept on Monday when you were still with us, but if you were not, we will do it right now. Okay, so ratio table is basically it's a big T. what I call a big T, and you'll understand very quickly why I call it a big T. So I write here my big T, and for example, I can write here rows, and here I can write crayons. And this model is similar to the open number line. It just looks different, but it still demonstrates how you are thinking. I especially like this model when for people that are thinking about the problem with the crayons with as repeated addition. When you are thinking 8 plus 8 plus 8 plus 8. So let me show you what I mean. If you had one row, you obviously would have 8 crayons. We have seen that how the box looks like. But if you had 2 rows, you would have 16, obviously. It would be 8 plus 8. Now, I want you to think for just one moment. How many crayons would I have if I had 4 rows? I'm going to pause the video for a second so you can think. Well, I'm back. So if you look at this number, isn't 4 twice as much as 2? So this is times 2. Well, this number right here is going to be also times 2. So times 2. So if you have 2 times 2 equals 4, 6 times 2 is, what do you think? Think about it for a second and pause it if you need it. And pause the video if you need to. Well, yeah, that's right. It's 32. There you are. Now, one neat thing that we can do with this is take the information that we have already on the table to do all sort of combinations with it. For example, in box number 2, we are seeing that there are 6 rows. So we can say, okay, if I know the information about 4, how many crayons would I have if I had 4 rows, and also how many crayons I would have if I had 2 rows of crayons. So I could, what about if I combine these two for a total of 6 rows? Would this be adding these two numbers? Let's add it up quickly. So 6 plus 2 is 8, and 3 plus 1 is 4. Right there, huh? So we are getting exactly the same number right here and right here. So, and it makes sense. We should always get the same result no matter what model we use. The final model that I wanted to show you, it's called, and I'm going to write it here, it's called a tile model. This is super useful when we are, for example, for people who deal with construction or people who deal with properties, when they are trying to determine how big should this be. So I'll show you what I mean. So I'm going to write here, tile model. Okay. So if looking at the box itself, we can see that the box has 6 rows. So I'm going to write them 6 rows, like 1, 2, 3, 4, 5, and 6. And also each row has 8 crayons per row. Sorry. So I'm gonna draw that 1, 2, 3, 4, 5, 6, 7, and 8. So if you look at this as some kind of tile, I can even draw it for you. Look at this. Let me see if I... Actually, this is what I'm going to do, because it's going to take me a while. I'm going to pause the video, and I'm going to resume the video when I'm done. I'll be right back. Okay, Liz, so I have just finished. I have to apologize because the tiles on this model should be exactly the same, but you get the idea. Imagine that they are all exactly the same. So look at this. We are still with having 6 rows and 8 columns. If you count all the tiles that is that are created by this model, if you start like counting, okay, 1 and 2 and 3 and ta-ta-ta-ta-ta-ta, until the end, guess what? If you spend the time counting, good for you. But you will get right here this, when you're done with marking all of them, you would get 48 as well. And this is especially useful, for example, when we talk about area later on, when we have a property and we know, okay, it's 6 miles per 8 miles. So how many square miles do we have in our property? We will be able to determine that with this. And it will be very clear in our mind how it works. So what we're going to do now, and hold on just 1 second, I'm going to check my cheat sheet and I'll be right back. Okay, Liz. So what we're going to do is we're going to do 2 exercises where you are going to be the one driving, and you're going to prove that you have understood the concepts of these models and apply them to 2 specific problems. So right now in the screen, you have the 2 problems that we're going to solve. And I would like you to use at least one of the models listed to represent and solve each of the problems. I would encourage you to use a different model for each of the problems so you get practice with more than one model and you don't get stuck in one way of doing things or one way of thinking. And you have them right here on the screen, the 4 models listed. The area model, I have not specifically explained it, so you can focus on the first 3. It's very similar to the tile array, but don't worry about it. Use the first 3. And once you're done, we will continue. So you may pause the video right now. Okay, Liz, I hope that everything went well. I would like to solve one of the problems for you, just so you get an idea. Let's go back to it. I'm going to solve a problem A, just, there is no reason for it, just because it's the first one. So let's read it together, see how I thought about it, and let's try to solve it. Okay, so we have that the kids at table E have 9 pencils in the supply box. The kids at table F have 3 times as many pencils. How many pencils do the kids at table F have? Okay, so as always, I always start with a sketch. So I have here my table. Let's see, I have here, boom. Okay, this is table E. And the problem is telling me that table E has 9 pencils. I'm going to write here, 9 pencils. Wow. Very good. 9 pencils. Now, then I have here another table that is table F. And the problem is telling me that in table F, I have 3 times as many pencils as in table E. Again, the way that I think about this problem is like, if table F has 3 times as much, is like having 3 tables E worth of pencils. Like I can say, let me see if I can do this. Let me see. I'm going to copy and paste. Can I do this? Let me see. Oh, okay. Give me just 1 second. I'm going to pause the video and figure it out. I'll be right back. Look at that. So it's like having 3 pencils, 3 tables E. Sorry. So they are going to have 9 here, 9 here, and 9 here. So I can understand this also as 9 times 3. Good. But what model can I use to also represent this problem and get an understanding or pass my understanding of the problem to somebody else? So the way I want to do it this time is with a ratio table. And if you remember from just a few minutes ago, a ratio table, I'm going to write here, ratio table. It's like a big T. Even the word table starts with a T. So it's very convenient. So I'm going to write here, boom, my big T, and I'm going to say like, for example, desk, table, just not to repeat table too much, and then here pencils. Now, if I have one table E, if I have one table E worth of pencils, I'm going to have, as the problem says, 9 pencils. But if I had 2, I would say, well, I have like twice as much. It's like times 2. So this number will be times 2 as well. Okay, so that must be, I know that 9 times 2 is 18. So very good. But in this case, the problem is telling me that table F has 3 times as many pencils as table E. So this would be like, I could say that would be like times 3. And of course, this is going to be also times 3. 3 times 9, which is absolutely 27 pencils. So right there, we can see both graphically through the sketch, we can through the expression that certainly is going to tell us that from our math facts or multiplication facts that is 27, and also our ratio table is going to demonstrate that 9 times 3 or 3 times 9, the number of pencils on table E, is 27. So now you got an idea. I hope that we are in agreement on how to solve this problem. I hope that problem B was not much more difficult than problem A. What we're going to do now is the following. You're gonna work a little bit more independently, and we're gonna go. Let me see if I can. I'm gonna pause the video for a second. So now remember, the next thing that I did with the class is, now that we have seen several exercises where we are using different models, my question for you, or I asked the class 3 different questions that I would like you to consider, write down your answer after you reflect on them. So number 1 is, how is each model like? I'm gonna create a little bit of a, the first question is, how are these models, alike? Okay. Now the second question that I would like you to reflect on is, how are these models different? So the same thing, but how are these models? Whoa, that is a scary R. And number 3, okay, is which one is the most efficient? Because if you have done several models for the same problem, you might realize this model is way quicker. So my question for you is, which one is the most efficient? Which one is the most efficient? Now, the most efficient model changes with the problem. So there is no like a single answer, but which one so far do you feel that is the most efficient for the problems that we have solved? So the next thing that I would like you to do, as I said, is to work a little bit more independently. And for that, I would like you to switch documents. And I would like you to go to the document that is labeled as student book. And I think I even put page 6 and 7. And this is this is page number 7. We used page number 6 in class, but you're not going to use it, or we have not used it in the virtual version of the lesson. And what you're going to be doing is this page number 7 independently. It reinforces and gives you more chances to practice the models that we have seen in during the lesson. Now, once you're done, finally, what we are going to be doing, actually, I'm going to stop before I give you the homework associated with this lesson. I'm going to pause for a second, and I'm going to prepare to solve one of these problems, just so you get an idea. I'll be right back. Okay, Liz. So let's solve letter B on the first exercise. That would be this one right here. So if you have done part A, basically it talks about that the box of crayons has 6 crayons per row. And part B is telling you that now we have a box that has 6 crayons per row, but it has 6 rows. So how many crayons are there? And it asks us to complete the ratio table and write an equation to show our answer. So let's see how we do. So now, instead of building the ratio table, I am giving you the ratio table. And as you can see right here, it says that one row is worth 6 crayons, or has 6 crayons. Very good. So obviously, 2 rows will have 12. So 2 is twice as much as 1. So the number of crayons, 12, is going to be twice as much as 6. Very good. So the same thing is for 3. You can think about it, okay, so 6 times 3 is equals 18. Or you can also see that, okay, if I know how many is 2 rows and how many crayons I have, if I have 1 row, if I combine them together, 2 plus 1 equals 3. So 12 plus 16 will be 18. Okay, so that is super cool. So what happens now with 6? There are several ways that I can do this. The first one that comes to my mind is, okay, 3 or 6 is twice as much as 3. So whatever this number is going to be twice as much as 18. Now, if you think about it, and let me pause it so I can work on it on my sketchbook. Hold on. Okay, so we have the problem right here in the sketchbook. It's going to be easier like that. So we can say that 6 times 6 is 36. Also, as you can see, as I was saying before, 6 is twice as much as 3, so it's 3 times 2. And of course, 36 is twice as much as 18. 18 is like 18 times 2. So now what I can say is that if I want to create an equation that represents this problem, I can say that whatever the number of rows that a box has, 6, 36, a million rows of crayons, is going to be multiplied by 6. Because 6 is the number of, I'm going to write it here, the number of crayons per row. And that is going to give us whatever result. In this case, if I plug in the numbers of the problem, since I have 6 rows, I'm going to write it here, 6 rows, times 6, which is the number of crayons per row, is going to be 36 crayons. Okay. So this is how to solve a problem letter B. I think it's 1B. Let me see. Is it 1B? Yeah, it's 1B. I hope that you didn't find that the other ones were much more difficult. And now what I would like to do is to move on to your homework. I have left the homework on a different document called Home Connections, and I think I even said that it was page 3 and 4, or I probably wrote P.3 and 4. So work on those problems. They will help you practice even more these concepts, and remember to write them all these solutions neatly in a piece of paper, in a journal, page so we can then add it later on to your journal in class. That's basically the lesson for today. I hope that you have enjoyed it. I hope that you have not had problems. And remember, as always, you can contact me if you have any questions. My phone number is 920-550-1007. And my email is fnoya at, and then, omro.k12.wi for wisconsin.us. Have a lovely evening, and hopefully I will have the next lesson ready for you very soon. Take care. Bye-bye.